gives the whole system potential energy. In the terms of Lorentz from more than 50 years ago, 60 years ago, it's available potential energy. It's the potential energy that can do work. And so when that happens, the crust then will thin. It will extend because you've taken this load off, you've given it potential energy, but the crust will still shorten on its margins. There's nothing stopping this convergence. And this is what we see in Tibet. Tibet's crust is extending, but we're still thickening crust in the Himalaya and on the northern edge of Tibet. Well, suppose that's right. What does this predict? How can we test this idea? First, there should be lateral variations in density and more easily measured seismic wave speeds in the mantle. There should be enhanced volcanism because when you've removed this mantle lithosphere, you've brought hot material closer to the surface of the Earth. You've lowered the pressure. Rock tends to melt at a lower temperature if it's a lower pressure, so you'll melt. You'll cause crustal thinning and extension beneath the plateau, which I've already shown you. The plateau will grow outward, and the surrounding region will grow as mountain ranges. And we expect that the surface elevation should go up when the blob of mantle lithosphere is removed, and then it should subside as the crust thins. So what do the data show? I'm going to give you only one example from each of those to test each of those ideas, but please rest assured there are more examples. This is showing a map of PN speeds. P is the P wave, the sound wave that you're hearing right now, that propagates in the upper mantle just below the crust. And when it's fast, when we have high speeds, we think the material's cold. When it's low speeds, we think it's hot. And you can see the red across the northern Tibet. I think you can imagine where Tibet is and where the Himalaya lies in this figure. The red across the northern part shows low speeds and therefore presumably hot material. So in this sense, we've passed that test. There's lateral variations. What about volcanism? I'm just going to show you some photographs. If you drive in northern Tibet, or in this case, if you get stuck in the snow in northern Tibet, you see volcanic rock on the hills. That black rock in the background is basalt, a common volcanic rock. You see it clearly there. You drive across the countryside, not much in the way of space. This is a very barren area, but the black on top of the hills is, again, basalt. Again, another picture, black in the distance, covering the hills. It's not a lot of volcanic rock, but it covers much of the area. So I would contend that the test, has there been an increase in volcanic activity? I think the answer is yes. What about crustal extension? I've already shown you this. I've given you this argument. That's where we started. Again, the test is passed. What about outward growth of the range in surrounding high areas? I'm going to take you up to the Tian Shan in this case. So the map shows Tibet in the middle, the Himalaya along the edge. Those you know your geography will see the Shillong Plateau. And the Tian Shan is the mountain range way to the north. It's the only place in the world with 7,000 meter peaks outside of the Himalaya and surrounding areas. It's about 300 kilometers wide. And geologists can estimate the amount of shortening, that is, the amount that the southern side has moved north relative to the northern side. And I think they would all agree it's at least 50 kilometers, but that's definitely an underestimate, but no more than 200 kilometers. If you had more than 200 kilometers, you'd have either a wider mountain range or you'd have a higher mountain range. So we have 200 kilometers. We can measure GPS again, GPS velocities. This is a map showing you velocities of points. Each arrow is one point that's been measured a few times. They're all relative to Siberia or relative to the Kazakh platform. The scale in the lower right may be hard to see, but I can tell you that the points on the southern part in the Tarim Basin, south of the Tian Shan, move north 20 millimeters a year relative to the area to the north. So if we take that 200 or less than 200 kilometer shortening, divide it by 20 millimeters a year, which is 20 kilometers per million years, this suggests that the mountain range is younger than 10 million years. There probably was a mountain range before 10 million years ago, but it must have been very low. Most of the Tian Shan must be built in the last 10 million years, long after India collided with the rest of Eurasia. And the simple logic is if you raise the plateau to make it higher, you put a higher pressure on the surroundings. I use the word pressure loosely in this case. It's like raising the water level in a water tower. You have higher pressure on the walls if you do that. And this is enough to move the Tarim Basin north and build the Tian Shan. So again, I would argue you've passed the test. You cannot digest this figure, but this is an example of all the places around Tibet where we think we've seen an acceleration in deformation in the last 10 or 15 million years. There's much evidence to support that. So the fourth outward growth of the range or plateau, in this case outward growth of Tibet, of the Tibet and the surrounding mountains, it passes that test. What about an increase in elevation? This will be the ultimate test for us, and I can tell you we still have some way to go. This test, if we fail, we're wrong. But this is the most important one. But some preliminary evidence suggests that we're on the right track. In the middle, you see the location of a point where an amazing fossil was found. You can see this is published just this year. And on the right, you see a long fossil, the green, not the rightmost, but the green part, where you see 50-centimeter long palm, fossil of a palm frond, a palm leaf, if you like. It's a big fossil. Palms do not grow where it freezes. There are no palms in the Arctic. There are no palms even with most of the United States. It has to be warm all year for a palm. And therefore, we assume that Tibet must have been lower. Even if the global climate was warmer back at 25 million years ago, we think that this says the plateau must have been lower than about 2,000 meters. It couldn't, or maybe 3,000 meters. It could not be as high as it is today. So in this sense, we've all of the tests, the idea that you've removed mantle lithosphere has passed these tests. Doesn't make it right, but it passes those tests. So I want to move on now to the implications for climate. And this is a summary diagram showing you climate change in various places. They're not climate change, it's really proxies for climate change. In each of these, there's a time series. The right-hand side is the present, and then if you move to the left, the first red line is 5 million years ago, the second is 10 million years ago, the third 15 million years ago, and so forth. And they're all showing some kind of change within the last 10 million years or so. I want to focus on only one, the one that's not even in Asia. It's taken in the left, Globigerinobuloides, that orange or red plot in the left, where there was a core drilled in the ocean floor on what's called the Owen Ridge. I'll show you more about the Owen Ridge in a second. But that core shows a big change in Globigerinobuloides around 9 million years ago. So the hypothesis I'm pursuing here is the approximate simultaneity of surface uplift 15 to 10 million years ago and the regional climate changes, again, since approximately 10 million years ago, suggest a cause and effect relationship. And what we're hypothesizing here is the rise of Tibet 10 to 15 million years ago strengthened the Indian monsoon. The logic is simple. It makes sense. The idea is that if you have a high plateau like Tibet, shown in black there, the plateau surface becomes warm because of the sun, heating it. The air above it is much warmer than the air at the same elevation, the same height, but over the lower elevations towards the equator. So that hot air over Tibet rises to the top of the troposphere, moves southward across the equator, sinks, comes back. When it comes back across the equator, it evaporates water, brings moisture, and the moisture, the heating of the atmosphere, when you rain that moisture, enhances this circulation. So the logic is simple. If you raise the height of Tibet, you make that temperature difference between the high plateau and the surrounding area even greater. You would strengthen the monsoon. A simple hypothesis. And there's a hint of a way to test it. But before I get quite to the test, this is a map showing wind speeds at 4 different times. In the winter, in the upper left or lower right, the winds blow, you can't see this probably, blow towards the southwest, but they're not very strong. In May, they start to strengthen, blowing towards the northeast, And the red in there is showing you the strongest winds. The strongest winds occur in summer. This is August, but throughout the summer. The strongest winds are up there in the Arabian Sea. And what that does, because of the interaction of the winds with the water, the ocean cools. Below that, you see again the August temperature. The ocean is cool, blue is cool. That coolness comes from water rising from great depth up to the surface. So it's deep water. That deep water brings nutrients, I might add, nutrients that other animals can live on. And one of them that lives on this, or it's not an animal, this is actually a plant, Globigerina boloides likes this time of year because it needs cold nutrients. And what's plotted here along the axis, the horizontal axis, is time. You're looking at about a year and a half, so that 1 on that scale would be January 1st, 1986. So 240 is late August. And on the other axis is the number of Globigerina boloides that fell into a trap that was moored in the ocean. So this is measurements made back in the 80s, 30 years ago. And you see the number per square meter per day of Globigerina boloides. And you can see that in the summer, just before 240 days and then near 600 days, there's many, many more Globigerina boloides. The thought is, or the understanding is, that Globigerina boloides thrives in that cold, nutrient-rich water that upwells. So it's a measure of the monsoon. So let's look at the geologic record. This is a record taken from a core in from the Owen Ridge, and age is plotted, or time going backwards, on the vertical axis, going back to 15 million years, and on the x-axis is plotted the percentage of Globigerina boloides, and there's a big increase at 9 million years. The time scales have evolved since this work was done, and this is closer to 9 or 10 million years with modern time scales, but a big increase. And that certainly suggests the hypothesis has passed this test. Just when we expect the high plateau to be there and affecting climate, we get a big increase in Globigerina boloides. But it just passes a test. It doesn't mean that the hypothesis is right. There are always future tests. And this same test, in fact, had another lifetime. Now here's a plot. On the bottom is a cross-section through the Owen's Ridge. The layers are sedimentary horizons, and you can see that they dip. A little harder to see are valleys in those ridges that were incised by submarine flows of sediment, rapid flow, that incised into this. But you see this is tilted, and if you think about a submarine flow, it wouldn't be going, it would go downhill or it would go across flat terrain, and that's not what you see. You see this happening in this tilted terrain. And what the authors of this paper have said is that the Owen's Ridge rose from great depth to approximately 1.5 kilometers, 8 or 9 million years ago. Well, so what? Why do you care about that? Well, when you put sugar in your tea, if your tea is hot, the sugar dissolves quickly. If you put salt in your soup and your soup is hot, the salt dissolves quickly. If you were to put calcium carbonate or If you were to put calcite or calcium carbonate into your tea, it would not dissolve. It dissolves when the temperature is low and the pressure is high. And the result is that if you have calcium carbonate, the shells of Globigerina boloides, if they sink and the ocean is shallow, they make sediment. That's the blue on the left side of the picture. But if they sink into deep water, they dissolve. It's like salt going into hot water, or sugar into hot water, except it's cold water. They dissolve and they don't reach the bottom. They're gone. So you can imagine if you lift some part of the seafloor that was deep up above to shallow depth, it will have no deposited calcium carbonate until you go shallow enough that it doesn't dissolve. And this is the hypothesis, that 8 or 9 million years ago, the Owen Ridge rose above the calcite compensation depth, and so we have preserved in the record only the period of time when the region was shallow enough that you could maintain this. Deeper levels, you would have eroded these calcium carbonate. And if one looks at a slightly larger size, it's not a big difference, but most of these organisms are only around 125 microns in dimension. Slightly larger, you see there's no change. The larger ones don't dissolve. They dissolve, but they don't dissolve completely because they're too big. And so the result of this is we think that the ones that's what's happened is since 8 to 9 million years ago, the smaller shells could survive and not dissolve, but earlier they did dissolve, and as a result, this is telling us nothing about the monsoon. In essence, we have to say that the hypothesis actually does not pass the test that I offered you a minute ago. We failed. That doesn't mean we quit, but we then ask a different question. If Tibet did rise 1,000 meters between 15 and 10 million years ago, and we do not see strengthening of the monsoon at that time, well then what role does Tibet play in the Indian monsoon? And that's the question I'm now going to ask for more of this. The most important quantity in this is what's called the moist static energy. You don't have to know much physics to know that you need to conserve energy at all time, and energy is the most fundamental quantity of all physics. The moist static energy is the sum of all of the important sources of energy in a parcel of air. The first term, CPT, depends on the temperature. CP is a specific heat at constant pressure. The second term is the latent heat. If you evaporate water, you have to put energy into the water, latent heat. The latent heat, LV is the latent heat of vaporization. Q is the amount, the fraction of the air that is water. And GZ is potential energy. You'd know that from very elementary physics. This is all per unit mass. That's why you don't see a mass in there. So the moist static energy is the most important quantity, and where you have intense heating of the surface, that will go up. And I remind you, you all know this, you know it better than I, that before the monsoon onset, India's hot, so it's got a big T, and it's humid. It's got a big Q. And I'm sure at some point India will experience a monsoon this year, but in the 2 weeks I've been here, I have not seen any evidence of it. Maybe we're still in the monsoon onset stage. So this is the most important quantity. And if one looks at a map of this quantity, moist static energy, it's not over the Tibetan Plateau. The maximum is not over the Tibetan Plateau. It's over the region just south of the Himalaya. This is a map I think you can recognize where India is, and you can see where Tibet is. You know where the Himalaya, you grew up with this geography, and I can't point it out. So the maximum is over India, not Tibet. So this is suggesting Tibet is not very important. Now, a second aspect of the theory is that the hottest air at the top of the troposphere should be over the region of maximum moist energy. And the top is a cross-section across the Earth from roughly 0 to 30 degrees. Under the word energy is North America. It's not very clear. Under the word upper is Africa, and then India, of course, is over the region, the pH in tropospheric. I blow that part up in the lower part of the plot, and you look at that, you can see India, and the maximum in moist static energy is over the Indo-Gangetic Plains, or the Ganga Basin. And the maximum temperature is over that area. That's the same place. So the simple logic of this theory works quite well. Now, there's a second part of elementary monsoon theory, and that is that the strength of the overlying circulation increases with the latitude of the maximum moist static energy, provided you exceed a threshold. You must exceed a threshold, but if you do, that's where the maximum lies. And this is a map of the whole world. On the left, you see Africa. You see India at the left side, North America on the right. And the maximum moist static energy is not only over India, it's over northern India. And you can ask the question, why is the Indian monsoon the granddaddy of all monsoons? The simple answer is that the maximum moist static energy over India is the largest in the world, and it's also furthest north. The maximum, that big dark red, is north of all other places, and that's an essential part of getting a strong monsoon. So, elementary monsoon theory. You want a large moist static energy, hot and moist, and the wind strengthens, the circulation strengthens if it can get far from the equator, as one has in India. You have the strongest monsoon for that reason. Now, this is a plot showing the results of 3 general circulation model calculations. The top one is full topography. I think you see where India is. You can see where the Tibetan Plateau is. The southern one is similar, except what the authors, Bus and Kwong, have done is they removed the Tibetan Plateau. So that it looks the same. The middle picture, if you look at the middle column, the maximum moist static energy overlies northern India in both cases. There's not much difference. There's a little bit of a difference because if there's a Tibetan Plateau, there is a high maximum moist static energy there. The middle is no topography. You still have maximum moist static energy over India. It's still there, but notice that it's farther south and it's weaker. The left-hand column shows the temperature in the upper troposphere. And again, in the top picture, it overlies the maximum moist static energy in northern India. The bottom picture, the same thing. In the middle one with no topography, the maximum temperature in the upper troposphere overlies the maximum moist static energy, but much farther south. What's going on? And the right hand shows rainfall, but we know topography is important for rainfall. What's going on here? What's happening is that the mountains, the Tibetan Plateau and the Himalaya, block cold, dry air, that's air with low moist static energy, from mixing with air over India with high moist static energy. And you get the same picture with the Tibetan Plateau and the Himalaya on top as you do without a Tibetan Plateau but a Himalaya below. When you take that away, that cold, dry air, the blue in the top of the picture, migrates onto the continent of India. It pushes the maximum that you can have farther south, and it prevents this large-scale circulation. In a very nice study done before this work by some people who are present in the room, in fact, this is a plot. Notice May, June, July, August is the time scale along the horizontal. The vertical is moist static energy over India. And this is results of 2 general circulation model runs. The dark black line is one with topography as we know it. The light line does not have that topography. That topography has been removed. And what you see is the monsoon, the dashed line, the horizontal dashed line is an approximate threshold you must achieve to have a monsoon. You see when you have the topography, you get to that threshold sooner by a month and a half. And you see that the moist static energy stays well above that threshold for a longer period of time than when you don't have that high topography. So, how does Tibet affect the South Asian monsoon? It blocks cold, dry air from the north and prevents it from mixing with warm, hot air over India and keeps the moist static energy low, prevents the moist static energy from being low and allows you to reach a very high value over northernmost India. Well, if that's the case, is Tibet irrelevant? And I'm going to offer you a test of whether Tibet is irrelevant to the monsoon or not. And for this, what we did is we correlated moist static energy over Tibet, the yellow line pointing at Tibet, with rainfall over India, over the whole of India. In the red line, we correlate one against the other. And if Tibet is important, we expect them to correlate. If it's not, we expect decorrelation. In this plot, first look at the upper left. This is a correlation of moist static energy over Tibet with rainfall in India in the early season, the early part of the monsoon. And it's a positive correlation. It's not high, it's only 0.4 or so, but it's definitely significant. Look in the lower right picture. This is the late monsoon season. This is from late September into the middle of October. Again, a correlation. Tibet seems to be important. It suggests that there is definitely a correlation between moist static energy over Tibet and rainfall over India, suggesting that perhaps Tibet plays a role. In the lower left is the main monsoon season. That's when 80% of the rain falls, and there's no correlation. That's not significant. So Tibet seems to be important early and seems to be important late, but not for most of the season. And so maybe Tibet's important because if Tibet had an important effect on even 20% of the rainfall over India, it might make a difference between a major and a minor monsoon, or a strong and a weak monsoon. So the test says, yes, Tibet is not unimportant, but doesn't seem to be very important. Okay, I'm going to summarize what I've said. India collided with Eurasia near 45 million years ago. The Himalaya and the Tibetan Plateau started to grow around 45 million years ago. A big change occurred 15 to 10 million years ago. Crustal thickening stopped and the surface began to subside. Tibet's height might have been 6,000 meters, and the surrounding area also rose. The monsoon did not strengthen at 10 million years ago. Our hypothesis there failed. The Himalaya without Tibet is crucial for the monsoon. Tibet is not crucial for the monsoon. And finally, still, maybe Tibet is important, but only for the early and late seasons. So this is a summary of where I stand. I've spent 25 years trying to learn what I can about monsoons and atmospheric science and all of this subject. And obviously I've had a lot of failure, but failure is good. You have to have failure in order to succeed. And for me, it's been fun. I've learned new topics. I've been challenged in new ways, and I've made a lot of new friends. It's been a pleasure. Thank you.
Thank you so much, Dr. Peter Molnar. और अब बारी है हमारे देश के जो होनहार स्टूडेंट्स हैं उनके पुरस्कार देने की. अर्थ डे नेशनल लेवल ड्राइंग कंपटीशन पुरस्कारों की अब बारी आ रही है. इसमें देश के 44 केंद्रों, जिसमें स्कूल, कॉलेजेस, यूनिवर्सिटीज के 6,000 स्टूडेंट्स ने पार्टिसिपेट किया और विषय था प्रोटेक्ट आवर स्पीशीज. So, Honorable Minister will be arriving in a short while. और जैसे ही वो यहाँ पर पधारेंगे, हम जोरदार तालियों से उनका स्वागत करेंगे. आज बच्चे आप लोग जो बैठे हुए हैं, किसी भी ओकेजन में हम चाहते हैं ना, उसको अपॉर्चुनिटी के रूप में लेना चाहिए. गप्पे और बातचीत के लिए बहुत टाइम मिलता है, लेकिन ऐसी चीजों के लिए जो ये अपॉर्चुनिटी है, इसको पकड़ के रखना चाहिए. क्या चीज कहाँ क्या काम आपकी जिंदगी में आ जाए, कुछ पता नहीं है. सो इस चीज को आप लोग ध्यान रखिए. दूसरा, ये जो हॉल है, मंत्री जी बस आने ही वाले हैं, तो मुझे लगता है कि मुझे उनके लिए आई जस्ट टॉक टू यू. तो ये जो हॉल है जिसको विज्ञान भवन कहते हैं, ये बहुत ही इम्पोर्टेंट हॉल है. इसमें प्रधानमंत्री जी, राष्ट्रपति जी और जो भी बड़े बड़े हमारे बाहर के राष्ट्रपति जी, उनके प्रोग्राम होते हैं. तो ये जो विज्ञान भवन है, ये अपने आप में बहुत एक साक्षी रहा है अलग अलग प्रोग्राम्स के. और जो लोग भी यहाँ पर आए हुए हैं, वो लोग, हम सब बहुत सौभाग्यशाली हैं कि इस जगह आने को मिला है जिसको देश सारा देखता है टीवी पर, लेकिन आज हम उसी हॉल में बैठे हुए हैं. तो ये हम सब के लिए बहुत गर्व की बात है. इसके पहले कि माननीय मंत्री जी यहाँ पर आए, बच्चों, आप लोगों के लिए ही कह रही हूँ, जैसे कि मैंने कहा है, क्या क्या चीजें यहाँ से ज्ञान सब जेब में भर के जाएंगे, आप अच्छे से ध्यान रखिए कि तुम ही गगन के तारे गिनना अगर मगर को छोड़ के, तुम ही गगन के तारे गिनना अगर मगर को छोड़ के, सारे सपने रखो जेब में रातें तोड़ मरोड़ के. तुम ही गगन के तारे गिनना अगर मगर को छोड़ के, सारे सपने रखो जेब में रातें तोड़ मरोड़ के. जन गण मन सम्मान हमारा, वंदे मातरम जान है. थाम तिरंगा करो घोषणा, हिंदुस्तान जवान है. थाम तिरंगा करो घोषणा, हिंदुस्तान जवान है. और जो दुनिया की सबसे बड़ी ताकत यूथ की, कितने सबसे सारी दुनिया में अगर देखा जाए तो यूथ सबसे ज्यादा परसेंट हमारे इंडिया में है, तो इसमें कितनी ताकत है, कितनी ऊर्जा है। तो सारे देश से सबसे ज्यादा कैपेसिटी हमारे देश में है, क्योंकि यहाँ पर यूथ सबसे ज्यादा है। और यूथ कितना जिम्मेदार है वो आज आपको दिखाना है, बातचीत नहीं करना है आपस में। तो आज माननीय मंत्री जी हमारे बीच में आएंगे और जैसे ही वो यहाँ पर आएंगे हम सब जोरदार तालियों से उनका स्वागत करेंगे। हमारा ये कार्यक्रम फिर आगे बढ़ेगा। और एक बात और, हम बहुत बहुत स्वागत करते हैं आवर चीफ गेस्ट ऑनरेबल डॉक्टर हर्षवर्धन जी, ऑनरेबल यूनियन मिनिस्टर ऑफ साइंस एंड टेक्नोलॉजी, अर्थ साइंसेज, हेल्थ एंड फैमिली वेलफेयर, डॉक्टर हर्षवर्धन जी। बहुत बहुत स्वागत है माननीय आपका आज के इस कार्यक्रम में। In India, we begin any auspicious occasion with the lighting of the lamp. Sir, आपसे विनम्र निवेदन है कि कृपया मणिदीपक को प्रज्वलित करके कार्यक्रम का परंपरागत रूप से शुभारंभ करें. I request the esteemed dignitaries on the dais to kindly join this inaugural ceremony. In India, we begin any auspicious occasion with the lighting of the lamp. So we are requesting our Honorable Minister to kindly light the ceremonial lamp to begin this auspicious occasion. हमारे यहाँ एक बहुत ही, there's an ancient prayer in the Indian culture, Asato ma sadgamaya, tamaso ma jyotirgamaya, which means lead me from unreal to real, from the darkness of ignorance to the light of knowledge and wisdom. थैंक यू सर। न्यू इंडिया की खासियत ये है कि वो सर प्रगति के आसमान की ओर उठाकर रखना चाहता है, लेकिन पैर अपने संस्कारों, अपने जड़ों, अपनी संस्कृति से जोड़े रखना चाहता है। कहते हैं कि मेघ और मेहमान बड़े भाग से पधारते हैं। इन द इंडियन ट्रेडिशन द गेस्ट्स आर हेल्ड इन द हाईएस्ट एस्टीम। डॉक्टर एम राजीवन सचिव से हम निवेदन करते हैं कि माननीय मुख्य अतिथि महोदय डॉक्टर हर्षवर्धन जी का स्वागत शॉल से करें। I now request Shri B. Anand, Additional Secretary and Financial Advisor, Ministry of Earth Sciences, to present a shawl to our special guest, respected Dr. Peter Molnar. लेडीज एंड जेंटलमैन, कोई भी काम अवार्ड जीतने के लिए नहीं किया जाता, बल्कि वो तो सेवा की भावना के लिए किया जाता है, सेवा की भावना के साथ किया जाता है। पर अवार्ड से सम्मानित होकर जीतने वाले को गर्व की अनुभूति जरूर होती है। We are now commencing the award ceremony. The ministry has instituted one Lifetime Excellence Award, 4 national awards, 2 Young Researchers Awards to recognize the outstanding performance by the scientists, engineers of Indian origin, in addition to Certificate of Merit for Scientists and other awards. The National Award for Women Scientists has also been instituted in 2018. May I request Honorable Dr. Harshavardhan and respected Dr. Peter Molnar and the dignitaries on the dais to please come in front of the dais for the award presentation ceremony. माननीय डॉक्टर हर्षवर्धन जी से हमारा विनम्र निवेदन है कि कृपया लाइफ टाइम एक्सीलेंस अवार्ड एंड नेशनल अवार्ड्स अपने कर कमलों द्वारा प्रदान करें. Ladies and gentlemen, the 2019 Lifetime Excellence Award in Earth System Sciences is being awarded to Professor J. Srinivasan. May I request Dr. Vipin Chandra JS to please read the citation.
Past 46 years, he embarked upon the development of simple monsoon models and used simple axismetric models of the monsoon to unravel the mechanism that governed the poleward migration of cloud bands in the tropics. In recognition of his outstanding contributions to Earth system science, the Ministry of Earth Sciences honors Professor J. Srinivasan with the Lifetime Excellence Award in Earth Sciences for the year 2019.
जोरदार तालियों से स्वागत करें हमारे अवार्डीज, हमारे देश के गौरव के, ये सभी हमारे देश के गौरव हैं. The National Award in Ocean Science and Technology is being awarded to Dr. D. Shankar, Chief Scientist, National Institute of Oceanography, NIO, Goa. Dr. Vipin Chandra.
Dr. D. Shankar has made significant contributions to the physical oceanography of the Indian Ocean. He played a significant role in the evolution of theoretical framework for understanding the circulation in North Indian Ocean. In recognition of his outstanding contribution to ocean science and technology, MoES honors Dr. D. Shankar with National Award in Ocean Science and Technology for the year 2019.
जोरदार तालियां और बधाई. The National Award in Atmospheric Science and Technology is being awarded to Professor S.K. Satish, Indian Institute of Science, Bangalore. Dr. Vipin Chandra will read out the citation.
Professor S.K. Satish has made original and outstanding contributions in understanding the role of light-absorbing aerosol particles on the radiation balance of the Earth atmosphere system. In recognition of his outstanding contributions to atmospheric science and technology, the MoES honors Professor S.K. Satish with the National Award in Atmospheric Science and Technology for the year 2019.
बहुत-बहुत बधाई आपको. The National Award in Geoscience and Technology is being awarded to Dr. G.V.R. Prasad, Delhi University. Dr. Vipin Chandra will read the citation.
Professor G.V.R. Prasad is recognized for his significant scientific contributions in the field of geoscience and technology in the country. He is a paleontologist known for his extensive studies on various Mesozoic vertebrate groups of India. In recognition of his outstanding contributions to geoscience and technology, MoES honors Professor G.V.R. Prasad with the National Award for Geoscience and Technology for the year 2019.
Congratulations. From last year onwards, the National Award for Women Scientists has also been instituted, and this award goes to Dr. C. Manikyamba, National Geophysical Research Institute, Hyderabad. Dr. Vipin Chandra.
Dr. C. Manikamya works on Precambrian geology and geochemistry, plate tectonics, crystal evolution, and metallurgy. Her studies provided deep insights in understanding the evolution of Archean greenstone belts, role of tectonics, and mental characteristics. In recognition for her outstanding contribution to geoscience and technology, the Ministry of Earth Sciences honors Dr. Manikamya with the Women Scientist Award for the year 2019.
Congratulations to Dr. Manikamya. और अब यंग रिसर्चर्स अवार्ड्स प्रदान किए जाएंगे. डॉक्टर रूना एंटनी, साइंटिस्ट, नेशनल सेंटर फॉर पोलर एंड ओशन रिसर्च, गोवा. शी इज बीइंग अवार्डेड फॉर हर सिग्निफिकेंट कॉन्ट्रीब्यूशंस इन द फील्ड ऑफ क्रायोस्फेरिक प्रोसेस and biogeochemistry of Antarctic snow and ice. Dr. Runa Antony. डॉक्टर अभिषेक साहा, साइंटिस्ट, नेशनल इंस्टीट्यूट ऑफ ओशनोग्राफी, गोवा को ये पुरस्कार दिया जा रहा है पेट्रोलॉजी एंड जियोकेमिस्ट्री ऑफ सेवरल रॉक सूट्स फ्रॉम वेरियस पार्ट्स ऑफ इंडिया के क्षेत्र में उनके उत्कृष्ट रिसर्च योगदान के लिए. Dr. Prashant Kumar, Scientist, Space Applications Center, ISRO, is being awarded for his outstanding contributions in the field of the satellite data assimilation in the numerical weather prediction models. May I now request respected Dr. Peter Molnar to hand over the Certificate of Merit to the Young Scientist Certificate of Merit in Ocean, Polar and Geosciences. Dr. Waliur Rahman, Scientist, National Center for Polar and Ocean Research, Goa. He is working in the field of Antarctic ice core, paleoclimatology and isotope geochemistry and has established the state-of-art instruments in the field of geochemistry in NCPOR. Dr. Arya Paul, Scientist D, Indian National Center for Ocean Information Services, Hyderabad. He has developed an ocean data assimilation system for the operational configuration of regional ocean modeling system. इन सभी को बहुत बहुत बधाइयां, जोरदार तालियों से इन सभी की बधाई और शुभकामनाएं दीजिए. Shri A.A. Gyanraj, National Institute of Ocean Technology, Chennai. His main contributions have been in the development of integral mining system, protocols and associated systems and analysis of deep water flexible riser system and remotely operated in situ deep water soil tester. Dr. Anil Kumar Vijayan, Scientist D, Center for Marine Living Resources and Ecology, Kochi. I request Dr. Rashid K to please receive the award on behalf of Dr. Anil Kumar Vijayan. He has done commendable work of implementing the field campaign of METAS, meticulously planned and motivated the project scientists for its successful completion. Dr. K. Maya, Scientist F, National Center for Earth Science Studies, Thiruvananthapuram. She has done extensive studies on environmental impacts of mining and quarrying of minor minerals from the river catchments of southern Western Ghats. Dr. Ajit Pandey, scientist, National Center for Seismology, has made significant contributions in the undertaking and coordinating the various field activities and database management for seismic hazard microzonation. Shri B.K. Thakur, Scientist D, Ministry of Earth Sciences, is awarded the Certificate of Merit for his significant contributions in the implementation of the Ocean Technology Program. As I told, that the clappings are the blessings, basically. So please do clap for the winners. जोरदार तालियां सभी winners के लिए. Certificate of Merit in Atmospheric Science, Dr. Sanjeev Bandyopadhyay, Scientist F, India Meteorological Department, Kolkata. He has made significant contributions in the upgradation of observational network and the implementation of Grameen Mausam Seva in the eastern region of the country. Shri R.K. Giri, Scientist E, India Meteorological Department, New Delhi. He has made significant contributions in the field of satellite meteorology. Dr. Anupam Hazra, Scientist E, Indian Institute of Tropical Meteorology, Pune. He has made significant contributions in the development of coupled forecast system for improving the seasonal prediction skill of Indian summer monsoon rainfall. Dr. Anumeha Dubey, Scientist D, National Center for Medium Range Weather Forecasting, Noida, but she is not present here, I believe. So we move forward. Thank you, Dr. Peter Molnar. और अब हम आते हैं हमारे महान देश की राजभाषा पर. पृथ्वी विज्ञान की तमाम जटिलताओं के बावजूद हमारे मंत्रालय ने संघ की राजभाषा के कार्यान्वयन के क्षेत्र में भी अपनी शानदार उपलब्धि दर्ज की है. मंत्रालय के अधीन भारत मौसम विज्ञान विभाग के प्रादेशिक मौसम केंद्र मुंबई ने भारत संघ की राजभाषा नीति के अनुसरण में राजभाषा विभाग द्वारा जारी वार्षिक कार्यक्रम 2018-19 में निर्धारित मदों का अनुपालन करते हुए अनुकरणीय उदाहरण प्रस्तुत किया है. प्रादेशिक मौसम केंद्र मुंबई की ओर से प्रशस्ति पत्र प्राप्त कर रहे हैं वैज्ञानिक एफ एवं उप महानिदेशक श्री कृष्णानंद होसालेकर. माननीय मंत्री महोदय से निवेदन है कि कृपया ये पुरस्कार प्रदान करें. बहुत बहुत धन्यवाद. और अब बारी आती है देश के होनहार स्टूडेंट्स की अर्थ डे नेशनल लेवल ड्राइंग कंपटीशन पुरस्कारों की. इसमें देश के 44 केंद्रों जिसमें स्कूल, कॉलेजेस, यूनिवर्सिटीज के 6000 स्टूडेंट्स ने पार्टिसिपेट किया और विषय था प्रोटेक्ट आवर स्पीशीज. और पुरस्कार के विजेता हैं लेवल 1 क्लास 5th और उसके नीचे यानी बिलो. 3rd प्राइज हासिल किया है चर्चिल वाई क्लास 4th वेल एकेडमी इम्फाल. सबसे पहले चर्चिल आएंगे। तानिशी तैयार रहेंगी। सबसे पहले चर्चिल। थर्ड प्राइज का हम अनाउंस कर रहे हैं। योर चर्चिल, प्लीज कम। दूसरा जो बच्चा है वो यहां खड़ा हो जाए, फिर नाम लेंगे तो आप ऊपर जाइए। प्लीज स्टैंड हियर। Second prize goes to Tanishi Sharma, class 4th, Venkateshwar International School, Delhi. First prize Nabi Rao, class 5th, Rayan International School, Sohna Road, Gurgaon. अब बारी आती है लेवल 2 की 6 to 10th स्टैंडर्ड और थर्ड प्राइज के हकदार रहे फरहान बी अहमद, क्लास 10th, मॉडर्न स्कूल, बाराखंबा रोड, न्यू दिल्ली। अपनी कल्पनाओं के कितने सुंदर सुंदर रंग भरे हैं इन्होंने, आपने इनकी पेंटिंग में देखे हैं। इसे तालियों में कमी न कीजिएगा। सेकेंड प्राइज रिया जैन, क्लास 10, सेंट जोसेफ को-एड स्कूल, अरेरा कॉलोनी, भोपाल। And first prize goes to Supriyo Das, class 8, Deiti High School, Hooghly, Zilla, West Bengal. और अब बारी आती है लेवल 3, 11th टू ग्रेजुएशन। और पहले हम थर्ड प्राइज की उद्घोषणा करेंगे। थर्ड प्राइज जो जीता है वो है जी ब्रज बिहारी शर्मा, क्लास 11, वेल एकेडमी, इम्फाल। सेकेंड प्राइज जीता है गुलशन कुशवाहा, BFA, सेकेंड ईयर, RMT यूनिवर्सिटी, ग्वालियर। फर्स्ट प्राइज जीता है ऋषभ ऐश, क्लास 11, बेगमपुर हाई स्कूल, हुगली डिस्ट्रिक्ट, वेस्ट बंगाल। Now we move on to the awards for the winners of 12th International Earth Science Olympiad 2018। ये प्रतियोगिता अगस्त 2018 में थाईलैंड में आयोजित की गई थी, जिसमें 38 कंट्रीज के बच्चों ने पार्टिसिपेट किया था। The Indian team won 1 silver medal and 1 bronze medal। माननीय मंत्री जी से विनम्र आग्रह है कि ये पुरस्कार अपने कर कमलों द्वारा प्रदान करें। पहले बच्चे जो हैं वो आ नहीं पाए हैं। अभिनव श्रीनिवास, क्लास 10th के, जो कि इंडिया टीम को रिप्रेजेंट कर रहे थे ब्रॉन्ज मेडल जीतने में। अब मैं आमंत्रित करूंगी वैभव खट्टर, क्लास 10, सेंट मेरी सीनियर सेकेंडरी स्कूल, उदयपुर, रिप्रेजेंटिंग टीम इंडिया, वन द सिल्वर मेडल। ये इंटरनेशनल लेवल पर हमारा नाम करके आए हैं भारत का, जोरदार तालियां। सिल्वर मेडल टीम इंडिया का इन्होंने रिप्रेजेंट किया था। और अब पुरस्कार वितरण संपन्न होता है। माननीय, आपसे निवेदन है कि कृपया अपना स्थान ग्रहण करें। आप लोगों से निवेदन है कि अपने मोबाइल फोन जरूर स्विच ऑफ रखें कार्यक्रम की गरिमा को बनाकर रखने के लिए. I request all of you to kindly switch off your mobile phones. Before the Honorable Minister launches the new website of the India Meteorological Department, let's watch a short film on this website.
Introducing MoES. Ministry of Earth Sciences feels proud to launch a new website, moesm.imd.gov.in, for India Meteorological Department. The website MoESM is dedicated to general public. It is designed in such a way that the information can be communicated without technical jargons to meet the requirements of public. The major services provided by the website entitled MoESM are warnings. With just one click, the website will provide multi-hazard warnings for next 5 days and also nowcast at meteorological subdivisions and district levels. Interactive map covers 150 stations spread across country, from which people will get latest weather update every 3 hours. Home page provides the latest satellite image, all India radar images, and lightning activity over the past 30 minutes. Satellite page displays the latest satellite imagery. Radar page will display station-wise radar products, radar reflectivity with lightning superimposed on them. Our services pane categorizes the major services provided by IMD. The 7-day city weather forecast, rainfall information across the country at district, subdivision, state and river basin levels. Agro-meteorological advisories for farmers. Information on monsoon. Cyclone updates and warnings. And climate services. Forecasts comprises All India Weather Forecast Bulletin, 5-day subdivisional and district rainfall forecast, extended range forecast for next 4 weeks, seasonal forecast, river basin scale rainfall forecast. In the bottom pane, MoESM summarizes weather across major cities of India. Apart from these services and forecasts, the website also acts as a centralized portal to all the meteorological offices in India to update the warnings, bulletins, and other data in real time. Keeping general public in view, MoES feels that the newly designed website, MoESM, will be an important tool for dissemination of information in an attractive and user-friendly manner and will meet the requirements of public. The website has been designed and developed jointly by the Indian Institute of Tropical Meteorology, Pune, and India Meteorological Department. The website now will be inaugurated by Dr. Harshvardhan, Honorable Minister of Earth Sciences.
Sir, may I request you to kindly launch this website by pressing the launch pad button. जी हाँ, the new website of the India Meteorological Department. माननीय मंत्री जी के कर कमलों द्वारा ये शुभ शुरुआत हुई. जोरदार तालियां. Sir, I again request you to kindly inaugurate the Agro-Meteorological Advisory Service app. इस ऐप का नाम है मेघदूत. आपको वही प्रेस करना है बटन सर. जी हाँ, मेघदूत का लॉन्च हो गया है. दिस ऐप इज अवेलेबल इन गूगल प्ले स्टोर.
मेघदूत ऐप. मेघदूत, a joint initiative of India Meteorological Department IMD, Indian Institute of Tropical Meteorology IITM, and Indian Council of Agricultural Research ICAR, aims to deliver critical information for farmers through a simple and easy-to-use mobile application. The app will make available weather-based agro-advisories that can enhance the production and income of the farmers through timely and context-specific advisories and accurate weather forecasts. The agro-advisories and the forecasts will be available to the farmers in English and 9 Indian languages at the click of a button. Farmers have to register with their mobile numbers, and the services are just a click away. Key features about the app are: Meghdoot will report the past observed and forecast information of temperature, rainfall, wind direction and humidity. Meghdoot will provide real-time location and crop-specific weather-based agro-advisories across India in local language. Farmers will now have easy access to district and crop-specific advisories. Presently, the app only provides information for 150 districts, and in future, it will extend to 670 districts in a phased manner. World-class technologies are being used to convey complex weather data to farmers using images, maps and pictures, thus paving the way for better understanding of the information by the farmers. The app has also been integrated with popular social media and messaging platforms like WhatsApp and Facebook. With a single click, farmers can share advisories from Meghdoot with fellow farmers through WhatsApp and Facebook. The app will be integrated with YouTube in the near future for the benefit of farmers. Meghdoot is available in the Google Play Store and App Store, offering its unique services to the farming community.
This app is available in Google Play Store and will be made available in Apple Store shortly. माननीय, अब कृपया नेशनल सेंटर फॉर सिस्मोलॉजी की नई वेबसाइट का भी शुभारंभ करें, रिमोट का बटन दबाकर. दिस इज नेशनल सेंटर फॉर सिस्मोलॉजी. इसकी नई वेबसाइट का विमोचन माननीय मंत्री जी के कर कमलों द्वारा होने जा रहा है. National Center for Seismology is the nodal agency for the Government of India for earthquake monitoring. It is also actively involved in the seismic hazard microzonation and seismological research. Mobile app named Rescue, real-time information system for earthquake. जी हाँ, माननीय मंत्री जी के कर कमलों द्वारा. It is available in the Google Play Store and is integrated with the website. तो बहुत बहुत बधाई इतनी सारी उपलब्धियों के लिए और हमारे देश के गौरवों के लिए. और ये हमारा परम सौभाग्य है कि आज हमारे बीच में देश के अनुभवी, कर्मठ तथा जुझारू राजनीतिक व्यक्तित्व डॉक्टर हर्षवर्धन जी मौजूद हैं, जिनकी सरपरस्ती हमारे मंत्रालय के लिए एक प्रेरणा है. आप सिर्फ भारत में ही नहीं बल्कि इंटरनेशनली नोन पर्सनालिटी हैं, जिन्हें नेशनली और इंटरनेशनली कई प्रेस्टिजियस सम्मानों से, अवार्ड से नवाजा जा चुका है. आप जैसे प्रबुद्ध व्यक्तित्व को सुनना हम सब के लिए एक सुखद और ज्ञानवर्धक अनुभव होगा. माननीय, मे आई रिक्वेस्ट ऑनरेबल डॉक्टर हर्षवर्धन जी टू काइंडली शो अस द वे फॉरवर्ड. ऑनरेबल मिनिस्टर डॉक्टर हर्षवर्धन, जोरदार तालियां हमारे माननीय मंत्री जी के लिए।
Dr. Peter Molnar, Dr. M. Rajivan, our Secretary of Ministry of Earth Sciences, Shri B. Anand, Additional Secretary and Financial Advisor, Shri Vipin Chandra, Joint Secretary Administration, Ministry of Earth Sciences, distinguished past secretaries of the Department of Ocean and Development and Ministry of Earth Sciences, Dr. Harish Gupta, Dr. P.S. Goel and Dr. Shailesh Nayak, all the other distinguished scientists, invitees, guests, awardees, dear school children, ladies and gentlemen. It's a very, very happy occasion for me to be your minister once again. Because as a Minister for Science and Technology and Earth Sciences, this is my second term and probably the first function in this term. And this first function starts with a bang. So many enthusiastic people celebrating the birthday of my own ministry with such pomp and show in the presence of so many distinguished guests, and more particularly the presence of our children, young students, who have added so much of grace and glamour to this function by their presence. And I was really happy to see that a lot of them were awarded for their contribution to our ministry by their innovative drawings and innovative thoughts and also propagating the message of the ministry through their paintbrush. And whenever I see these children, I always feel so happy and indebted, because over the years, in my 25 years of public life, I have felt that for everything that we do in the ministries, howsoever difficult it may be, but if we have the children with us, they are, I think, the most powerful messengers of our message. And if we can really involve them in a big way, we can work wonders, we can solve the most Herculean tasks, and we can take our message to even the remotest corner of the country in the best possible manner. So I would suggest that there are so many good things that our ministry does, but not many people in this country know about it. And once the people know about it, a lot of parents would like their children to become scientists in this ministry, and scientists for weather, scientists for ocean technology, scientists for seismology, etc., etc. It is only because people don't know much. They know, but not to the extent that the country should know. So, I think as a matter of policy, we should start a good quality brainstorming in our own ministry about how we can use the potential and the acumen of every child studying in the school and the colleges to learn about our ministry, to know what we are doing, and also to become the strongest possible messengers of the scientific message and the public welfare that we do through our ministry. I very distinctly recall my own program that I launched 25 years back. And whenever I see these children, I always go back to that program. We had launched the polio eradication program in the country for the first time in Delhi 25 years back. And when we were supposed to have the first pulse polio program activity on 2nd of October 1994, those who can recall 1994 will recall that suddenly the country was plagued with plague. And we had plague in Delhi, we had plague in Surat. I had been working with all my health people and other department people for almost 9 months. But everybody started advising us that if you have plague in the city, and during this period if you still go ahead with your pulse polio program on 2nd of October, that was the birthday of our father of the nation, because the mothers are frightened, maybe because of plague, it is very likely that the mothers may not bring their children to the polio kendra, and a program for which 9 months have been spent, it will fail in its aim and mission. And once it fails in its first attempt, nobody will ever try to get into this program again, and India would have lost the opportunity of even thinking about eradicating polio from the country, because at that time we were home to 60% of the polio cases of the whole world. I distinctly recall that we used to brainstorm, and that's why I always tell everybody that in your own departments, brainstorm regularly with your people to find out solutions to the problems of the country. So we called the Director of Education, and more particularly the Director of the Primary Education, to my office, and I told him, I have a very small task for you, can you help me? And I told him the whole situation. The program was going to be on 2nd of October, and we called the Director of Primary Education of Delhi on maybe something like 27th or 28th of September, just about 4 or 5 days before the... Everybody was quite, you can say, desperate or maybe frustrated what's going to happen. So I told the director, can you help me in giving a small official homework to every school child in Delhi and more particularly in the primary schools? But I said you have to give it officially and it has to be given on 30th of September. And the simple homework was for every child, that every child is supposed to come back the next day on 1st of October with a small paper on which he has written the name of 10 small children less than 3 years of age. At that time it was 3 years of age in the first year. Later on it was 5 years. On a piece of paper, and any 10 children who live in the vicinity of his house, let him write the names of 10 children and bring it to the school. That's all. That's the only homework. And this homework had to be delivered through the route of the principal and the class teacher. And on 1st of September 1994, every teacher had to ask the child whether he has done his homework and he has to show in the class that piece of paper on which he has written the name of those 10 children. And then the second part of the homework was that on 1st of September, when it has been done in the school, the teacher will tell the child that there is another homework for you today. You have to go back home and ensure that you meet the mothers of these 10 children and request them to bring their child or your younger brother or sister to the polio kendra on the next day, or remind them on the 2nd of October. This is a small innovative idea that emerged out of a small brainstorming. The homework was given to millions of children. The children did their homework. The teachers also did their homework. And on 2nd of October 1994, in spite of a plague, we had a successful pulse polio program where 1.2 million children, they came with their mothers, virtually everybody. And there was a child, I still remember his face, in a very poor colony of Delhi, that's Mangolpuri, who brought almost 346 children along with their mothers to the polio kendra. So, that is the power of these students. And after that we have tried it. Later on I became at that time I was only the health minister. But later on I became the education minister, and there was all those 3 years when I was health minister also and education minister also. So we combined both these specialties and used the children or the education people in health and used health for education, and this combination became so powerful. So when I saw these children and they being rewarded, I was just reminded of that, and I think the success of that story. It was not that they were doing that on the same day, but we had institutionalized this in the schools. We had made polio Sainiks out of children, and we institutionalized this in a way that we gave awards to these children as polio Sainiks to many of them. And then you all know the history, that when we could do it successfully in Delhi, it became a national program, then it became a program of Southeast Asia. Then when India could do it in 95, then Nelson Mandela launched Kick Polio out of Africa in South Africa. And today, because of the commitment of these children and so many Indians, we are a certified polio-free nation, a nation which was home to 60% of the polio cases of the whole world. And for last 8 years now, last 8.5 years now, we haven't seen a case of polio-affected new child in a country which was home to millions of such cases. The last case that we saw was in Howrah on 13th of January 2011. And in March 2014, we were certified as a polio-free nation by WHO. So I was just wondering, while I saw these children getting awarded, I was thinking that in this, till the next Earth Sciences Ministry's birthday, we should dedicate this 1 year to some activities where we think of brainstorm and think of using the capacity, and I am sure the children will find it very, very interesting. We should make sure that maximum number of students in the country, we make them familiar with what we are doing, not only theoretically. We can invite them to our laboratories, we can ask them to come to places in Chennai or in Pune or in Delhi or in Hyderabad or wherever we have our centers, and institutionalize all this. We can even spend money from our own, like we do in the India International Science Festival. We ask our parliament members to send 5 children from their adopted villages, we pay for their expenses, we pay for their stay, we pay for their travel. They spend 4 days. They are from every village of the whole country, at least the adopted villages. And they spend those 4 days in the India International Science Festival, and when you see how much they enjoy and how much they feel happy, that is a real treat to watch the glow on their face, the happiness on their face, and when you see that happiness on their face, you all feel very elated and satisfied. So I would suggest that next year we should make it some sort of a dedicated to the children of the country. This whole ministry dedicated to the school students of this country. That should be the theme of next year. This just came as a thought to me. This is for all there are so many senior people, and I have to salute their commitment that in spite of having become retired secretaries, they never retire, and they are never tired. They are always involved in all our activities. They come always with all those bright ideas, and so many others are there. Our IMD, DG, and everyone is there. So, and this is a very, very good occasion and happy occasion for me, because all these 3 things that you have done today. One is that MoSam website. You know, I have been asking for it for all these years. Every time I used to ask for it, you used to tell me that it is in construction phase, it is in construction phase. I was always wondering what is this construction phase going on for years and years. But now you have got it released. And then the other Meghdut thing also. This Meghdut is going to be the biggest boon for the farmers of this country. Because there is hardly anyone in this country now who doesn't have a mobile phone, who doesn't know about an app, who doesn't know how to download an app. We were like doing all this business of helping the farmers, advising the farmers through the text message. And I remember that in one cabinet meeting, the Prime Minister himself, and he had a meeting with you all also, and he said, now forget about these text messages, we need to have an app and all. So now you have this Meghdut app. I have been told that this is so comprehensive that any farmer in the country, in any part of the country, after having downloaded that app, what's going to happen to the weather, what's going to happen to the forecast about rains, etc. in the next 5 days or so, in his own field, in his own district, in his own surrounding, he can see that on the app. And I know for sure that how much important it is for the farmers to know. I remember that book that I released in the Earth Sciences Ministry in 2015 January, I think it was 2015 January, or where the National Council for Applied Economic Research had written that the information provided by the Earth Sciences Ministry to the farmers, and at that time it was for a limited, you can say, field, that was giving a positive impact of 50,000 crores in the GDP of India. That was something which I remember in 2015. Today, when all these calculations are done, and that was only the time when it was being delivered through a text message. Now, when you have all this app also, it's going to work wonders, and I think Prime Minister will be very happy to know about it, because he has a very strong commitment for the welfare of the farmers. He has been wanting that the farmers' income should be doubled by 2022. And all the science ministries have so many programs in which we are trying to help the farmers through big ways. And then finally the app that you have, the website that you have created for seismology, that's also going to be very, very interesting. I had the privilege to visit virtually every science lab in the country in the last 5 years, and that has been the greatest blessing for me to have a darshan of all that's happening in science in the whole country. But I still remember that place Koina, which was about 200 kilometers from Pune, where I had gone and inaugurated that program in which because nobody in the whole world is maybe doing a research on how you really establish the cause of these earthquakes, if you can really predict those earthquakes. Right now we can't do that, but the level of work that we are doing, that in a place like Koina in Maharashtra, where you have continuous earthquakes for almost 50 years, and there you are going deep into the rocks. They have already gone 3 kilometers inside. They want to go up to 5 kilometers and put sensors at every few meters or whatever, and then take continuous observations. And now after these continuous observations, they are in the process of making interpretations out of those observations. And they were telling me that accidentally they have found something for biotechnology or biology also while going inside. They were searching for causes of earthquake, but they got something else which is going to help us in maybe health or in biotechnology. So this in fact is a real treat that I enjoyed over the years. And then the studies inside the oceans, and particularly the visit that I had made to Lakshadweep. I always remember that with nostalgia, because the way we are now converting that ocean water into sea water into potable water. And believe me that I myself drank that water, what they had converted. That water I drank in Lakshadweep, converted with the help of the desalination plants created by my own ministry. It is certainly much better and much tastier than our government in Delhi provides to the Delhiites. So that is another big, I think, revolutionary thing which could become a big desalination mission. And now with the Prime Minister's passion for the next 5 years, his first important passion is to ensure that we are able to solve the issues related to water in the next 5 years, and we can really provide potable water, disease-free water, water which can help in maintaining good health, and that through to a piped water to even the remotest part of the country. That is an important dream of the Prime Minister. He's created another specialized ministry, Jal Shakti Ministry. I'm sure that one of the missions of this ministry can also be to help the Prime Minister in fulfilling his mission and contributing as much as possible through this ministry for the betterment of our countrymen. So there are a lot of things, in fact, which are happening. Weather forecasting, I know I had the privilege of seeing all those big petaflop facilities in Pune and Delhi, and we are now, I think, the number 4 in the whole world. And every time they meet, they say, we very soon will jump a little up also. Tsunami, we know, and from a situation in 2004 where we were caught unaware, now we are probably the number 1 in the whole country. And then, of course, there is IMD's accurate prediction of cyclone Fani and the excellent field work they have done about these disaster management agencies who helped in saving thousands of precious lives. I think all these things need to be commended, and officially the scientists of the ministry, they need to be congratulated. They have started these heat action plans, and then IMD is also providing these warnings to these tropical cyclone warnings to 13 countries. A number of things. I think most of you are familiar with the ambitious plan for weather forecasting, where now In 2014, IMD was using a weather prediction model with 25 kilometers resolution. Now it has been improved to the resolution of 12 kilometers in 2017. And prediction system, this ensemble, state-of-the-art global ensemble prediction system, it was commissioned on 1st June, which is one of the best in the world. Then now these agro-meteorological field units also, we are in the process of establishing in all the districts of the country by March 2022. An year when Prime Minister wants to deliver a new India to all Indians, where we will be able to cover almost 80% of the 94 million farmers in the country. So, there is a long list of great things that the department has done. They gave me a very big lamba chala note, but I don't want, because all these people who are here, they are all people related to Earth Sciences Ministry. We do know about all the laudable things that the ministry has done. I would use this occasion to congratulate all the scientists, and more particularly the awardees and those who got the most distinguished lifetime awards, and of course to our dear students who made us proud and who have inspired us to do some better things for future. I would suggest that we should use this occasion to take some sort of a pledge or a resolve. When we go back in our own departments, let us very passionately write what are the problems which the country still encounters or faces, and what are still the sufferings of the people of India. And out of those sufferings or the problems which we have even after 70 years, what is that we can solve? What is that we can help the society through our scientific capability and acumen? And then start working on them, develop dreams about those, around those problems, and then work passionately to ensure that every year on Earth Sciences Ministry birthday celebrations, you have something new to tell to this whole world, and which has not been done anywhere, but it is being done here. And we have some problems of the people solved in a better way during the past 1 year. I think if we go back with this mindset, I'm sure that celebrations like this will become more worthwhile. And once again, thanks all of you, and especially thank you Dr. Peter Molnar. I'm sorry I had a lot of activities during the course of the day, so I couldn't hear your lecture, but I will certainly have a copy from them about what you have delivered, and certainly go through that. And thank you for all your support and guidance. Namaskar, Jai Hind.
बहुत बहुत धन्यवाद माननीय। स्मृति चिन्ह, जैसा कि नाम से ही जाहिर है, इस कार्यक्रम की मधुर यादें अपने में संजोए स्मृति चिन्ह हम हमारे मेहमानों को भेंट करना चाहते हैं। I would like to request respected Dr. M. Rajivan, Secretary, Ministry of Earth Sciences, to present a memento to our chief guest, Dr. Harshvardhan, as a token of our immense respect and to honor. Requesting respected Dr. M. Rajivan to present a memento to respected Dr. Peter Molnar, our special guest. May I now invite Shri B. Anand, Additional Secretary and Financial Advisor, Ministry of Earth Sciences, to propose vote of thanks. कृपया आभार प्रकट करें.
Honorable Union Minister of Science and Technology, Earth Sciences, Health and Family Welfare, Dr. Harshvardhan ji, Dr. Peter Molnar, Distinguished Professor, School of Geological Sciences, University of Colorado. Dr. M. Rajivan, Secretary, Ministry of Earth Sciences. Dr. Vipin Chandra, Joint Secretary, Administration. Distinguished scientists, ladies, gentlemen, and children. It gives me immense pleasure to propose a vote of thanks at the end of this Ministry of Earth Sciences Foundation Day function. Firstly, I express my sincere gratitude to the Honorable Union Minister of Science and Technology and Earth Sciences, Dr. Harshvardhan Ji, for sparing his valuable time to be with us on this occasion and sharing valuable anecdotes from the launch of the pulse polio eradication efforts in Delhi way back in 1994, and also launching the Meghdut app and the new website of the department. Sir, under your guidance, during the second stint of your innings, this ministry would certainly endeavor to redouble our efforts and reach out to the children and ensure that more and more children are motivated to join the Ministry of Earth Sciences family. For the last 5 years, the minister has been providing us guidance, inspiration, and excellent support in all our activities, and we look forward to his continued guidance in implementing the various programs of MoES during his second stint also as our minister. We are extremely grateful to Dr. Peter Molnar, Distinguished Professor, School of Geological Sciences, University of Colorado, Boulder, for being here to deliver the Foundation Day lecture, the interesting lecture on the Indian monsoon and the effect of the Tibetan Plateau and Himalayas on the Indian monsoon. My customary congratulations and thanks are also due to the national awardees, winners of certificates of merit for young scientists and engineers, winners of Best Employee Awards, winners of school children drawing competition, for having taken the trouble to come all the way here and participate in our function. I am very sure all the young scientists from the MoES institutes and other academic institutes would have benefited a lot from today's deliberation, particularly the morning scientific sessions on earth sciences. We would like to thank all our former secretaries, Dr. P.S. Goyal ji, Dr. Shailesh Naik ji, and other honored guests for their presence today. Last but not the least, I thank all my colleagues from the Ministry of Earth Sciences who have helped in organizing this function in a very grand manner. Thank you.
Thank you so much. I request all of you to kindly stand up for the Indian National Anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
माननीय मंत्री जी, आपका हृदय से धन्यवाद और आभार कि आज आप हमारे बीच में पधारे. Thank you so much, Dr. Peter Molnar, for being with us. And